Hello viewers, welcome back to my channel. Today we'll be going to general topology. So what is topology? Topological space, definition and types. Let S be a non-empty set. A family class top of a subset is called a topology on X if and only if it satisfies the following issues. In topology, there are some issues to be satisfied for us to say that it is a topology. So we have a three conditions for a topology to be satisfied. One is X an empty set belongs to top, where file is an empty set. This symbol is an empty set, which we call it as a file. Then two is the arbitrary union of a set belongs to top is a member of what? That is, the arbitrary union of any set that is in top belongs to what? Top. Our top is the symbols for what? Is the symbols of topology. So, and the last issue is the intersection of any two sets in Tor belongs to Tor. The intersection. When we talk about an intersection, it means what? The common element in given set must belong to what? Must belong to what? The members in what? In Tor. And if you have it, we have the final intersection. So if these three issues satisfy, we can now say that what? It is a topology. So our X is a non-empty set. That is, our S is what? Can never be what? Empty set. That is, our S must have a value, must have an element. So when you have a three issues satisfied, we call it what? A topology. That is, X and empty set belongs to Tor. Then the arbitrary union. Arbitrary union is the union of the element present in both given elements. Is we call it arbitrary union. And then the last one is what? Final intersection, the common element among them. Once the three issues is satisfied, you can now say what is a general, is a what? Is a topology. So the pair S and phi is called a topological space. Remember, when we're talking about a space, we have a what? A space means a pair of two things. So whenever we have a space, it means we are talking about two things in one. So the pair X has an empty set, then phi is an empty set. It's called a topological space. So we'll be going to types of topology, types of topology. So we have discrete topology, we have indiscrete topology or trivial topology, we have cofinite topology and co-countable topology. When we talk about discrete topology, let S be a non-empty set. If Tor is the class of subset of X, then Tor is called discrete topology. That is, if our T is a subset of S, we call it a what? Topology. Given that if you have X, given that our X A, B, C, and we have our topology, our top as empty set X, then A, then AB. If we look at this element in Tor, our Tor is a subset of X. Why? Because we can find A here, we can find B here, we can find C. Let me put C, another C again. So A is common here, AB is common here, then C is common here. Since element that is there is also present here, so we can now say what? T is a subset of X. So if you have something like this, so we call it a what? Discrete topology. That is, if Tor is the class of all subsets of X, then Tor is called what? A discrete topology. So together with X and empty is discrete topological space. Remember that I talked about it earlier that whenever we have a pair of X and empty set, we're talking about a space. So when you have it together with it, it means what? It's a discrete topological space. The second example is in discrete topology or trivial topology. Let S be a non-empty set. If Tor X and empty, then Tor is in discrete topology. So in discrete topology, we only have elements, only two elements that must be present. That is the empty set and what? The S itself. Whenever we have an element which is S and empty set, then the set called what? Then it is called topology. So that is containing only two elements. That is Tor is equal to what? The empty set and the given element. That is our X and empty set. So whenever we have a Tor having only X and empty sets, we call it a what? Indiscrete topology or trivial topology. Together with X and empty set, you can say is what? It's an indiscrete topological space. Then number 3 is cofinite topology. Let S be a non-empty set. If Tor belongs to Tor and all those subsets of S containing whose elements are finite, then Tor is cofinite topology. So if you have Tor, U is a subset of X shows that U is equal to empty set, or U of C, that is U complement, is finite. If U complement is finite, then you can call it a what? The topological is called a what? A cofinite topology. In this cofinite topology, if you consider that our empty set belongs to Tor and our X is a subset of what? All elements, that is all those subsets of X whose complements are finite. You are able to find if you are able to find a what? A complement of what? A complement of the set. And if the complement of the set is finite, that is it is finite, that you can able to what? Get a value for it. So we can call it what? Cofinite topology. But if the subset of X whose complements are countable, so we call it a what? Co-countable topology. So this if our topology, we can say in this topology we can find what? An empty set. So that's why I said that what? An empty set, if empty set file belongs to Tor. And if our U is equal to empty or U complement is finite. If our whose in cofinite topology, if our subset of X whose cofinite is what? They are finite, we call it the complement must be finite in cofinite topology. But in co-countable topology, the subset of X whose complement are countable. That is the subset, the complement must be what? Countable. So when the subset of S is countable in topology, we'll call it a what? Co-countable topology. This is the types of topology, and I've explained better. Stay tuned to watch my next video on examples of topology.